Another day, another new motor for competition racing, 1/10 touring cars, 17.5, 13.5, and this time it's from Fantom. Wasn't long ago they had a version 2, and not long before that version 1. Now this is the new version 3. There's two versions, an R for Rev and a T for Torque. They've got 17.5s and 13.5s. Well, they've got the R version of 13.5 here at the moment. And initially just a red box. The version 2s were also in red boxes after a while. They were blue for a while and then they became red. Before we have a look at it, let's just see what they say. I've just got their release sheet here about what they're saying about it. Again, it says the highest quality stators and rotors, premium grade Kawasaki steel. Then new and improved stator design for super low ohms resistance. That's very good. Providing more power, more RPM, more efficiency. So everything's getting better. Outfitted with a new and improved super high strength ultra select premium grade neodymium rotor for extra horsepower, superior fade resistance. It's all looking good. Why settle for just an all-purpose motor? Well, I don't know whether they're referring to their previous one. Anyway, they then clarify specs, R&D done in the USA, new rotor design, new stator design, ultra select heat resistant magnets, sensor board improved for deviation accuracy again. All the manufacturers seem to have difficulty getting the sensor boards to be nice and equal. New venting design for maximum heat dissipation. Well, they were a little bit behind the curve with the holes in their cans compared to all the latest brands from Muchmore, R1, Motive, etc. Premium grade steel, yeah. Maximum size allowed on the copper wire for lowest resistance. High power, low resistance, thick copper, gold plated lugs, collector ring, all good. Aluminium end plates, infinite adjustable timing, high RPM precision bearings, all good stuff that most of the manufacturers go for. So let's have a look at one. First we notice it's red with a sort of a metallic red colour with nice black ends and bigger cooling vents like other manufacturers. Now you can see all the coils inside, get the air flow through. It's looking good here, plenty of gaps here around the front collector to get the air through. Some little vents on the end bell too, which gets the air flowing through. Open end for the bearing so you can oil it, clean it. 3 screws on the end bell, good for good location. Nicely readable this time. Markings for timing. So only says from 20 to 60, which is enough. ABC. Those are the very thick bent solder lugs here. Gold plated. Said the gold plated collector ring inside, you can see. And that is the red one. Now the previous one, I've got a version just if you want to compare it here. This is the previous one here. Was a sort of a blue colour. Lugs look the same to me on top here. Don't look like they've changed. The collector ring front looks the same. The actual design of the machine front looks the same. Looks like they haven't changed that either. It's just the holes, more holes. End bell. They've kept the legends the same. So the changes are going to be when we measure them, see what the differences are. I've got all the specs from other makes of motors, so be down to, before I test it, you can feel the magnetic strength, nice and chunky like most of the other manufacturers now. Be able to take it apart, measure all those things and test it for kV, etc. How to tell the two motors apart. Well, this one says V3R here and that one says V3T, and it's also just written not so clearly underneath the Fantom word there, V3R and V3T. Otherwise they look identical to the eye. Taking the two motors apart, this side we've got the Torque, the V3T, and this one's the V3R. Now the parts look identical. Looking at the sensor board, which is supposed to be special, it's just got 3 support columns. Most of the other manufacturers are now using a completely circular support to enable them to get it on square. So this one's still got 3 columns, which means that it has to be pushed on square and soldered up. Both the sensor boards are the same, the end bells are the same. On the motors themselves, inside it's got FT540-V2.1 on both of them the same. That, I don't know if that refers to the whole motor or just that plate. You can see the construction now, the heavy rivets that they used on the previous motor to stop these moving around. These are quite thick plates, heavy soldering, and a bit of the wires held, you can't see it, well, wires held with a bit of epoxy to stop it moving. There's no excessive insulation to block the airflow, which we've seen on some motors. Are they the same stators? Well, the only way to find out is by weighing them, really. Let's just get the scales, see if there's any difference, because there is a difference in the weight somewhere on these motors. So now this is the R version. It weighs 104.6 and the Torque version weighs 106, so that's where the difference is. Whether that's just a random winding thing, the wires look the same. I haven't measured the stator length of the laminations yet. There might be one more lamination on the Torque one. I'll just do that in a second. Now the rotors you would think would be different. Now on here it says FAN19414S 12.5 millimeters HT raw spec, and I've measured it. It's 12.50 millimeters in diameter. On this one it's exactly the same. Everything on it is written the same, and it is 12.50. Now it's interesting, the length, I've seen these are slightly longer than went before. These are measured at 25.75, the magnetic part, which is the metal end to metal part, not the black balancing part, which has got a little bit of epoxy for balancing it. 25.7, they both measure exactly the same. Most previous manufacturers have been about 24 millimeters long, except for the Motive, which had I measured about 26 millimeters long, so which is probably the same. Oops, measuring it there. You just measure it to the ends. It's about 25.7, near enough. Oops, and both of them the same. So is there any difference between these rotors on selection? So we do the Gauss readings here, turn it on, just 0 near enough. Let's do this one first, the R version, negative pole 1500 and something, 1518. So very strong rotors. The motive was, the other strong one was almost exactly the same, around 1500 Gauss. I wonder if they're buying the rotors from the same people. So that's 15 minus 1514, and pretty well made. They seem to be about right each side. Let's try this other one. About the same. They're slightly stronger on one pole than the other, but I should imagine they meant it to be the same rotor. So that was on the Torque version. Whether or not they select one that's fractionally higher, it is fractionally higher, but not much in it. So really they're same rotors in these motors. The only difference seems to be on the Stator, with the Torque one being slightly heavier. Now to measure the stators, I'll just do that in a second. Measuring the Stator laminates. On this time they've got the epoxy doesn't come all the way around the edge, giving you the metal end halfway up, so you can actually measure the lamination length without guessing it. Before, the epoxy came all the way up and made it much longer than you could actually measure the metal part. So you can just get it on. Seems to be about 19.53 on that one, and it will vary, I expect. No, pretty much 95.2. It depends where you measure it, slightly under. So we'll say it's about 19.5. It's slightly narrower at one end than the other. So 19.5 on the R version. Torque version, it's over 20. It looks like it's one lamination more. It's about 20 millimeters. 20 millimeters, so that's where the difference is. There's just one more lamination on the Torque one. Center board ends are exactly the same. Nice steel plates with threaded inserts, so they won't strip out. But the Hall effect devices, 3 on each one, you can see by eye that they're not perfectly all in the same position. I don't know if these are soldered in by hand, but they're not perfectly aligned. Some of them you can actually see that one is further away from the edge that way, and the little white lines it's supposed to be set in, it doesn't actually line up. So they say they're going for better sensor boards, but I don't see it. Checking the calibration of the meter with the probes connected together, 0.001, so it's pretty accurate on the 0 end. Resistance of the windings on the V2R, it's about 0.039. I've seen 0.038 on the R1, so it hasn't beaten the R1, but 0.039 I think is the next best one to the R1. On the V3T, it's only reading about 0.041 on the resistance, which seems a bit higher than the Rev one, which was reading 0.039. As supplied, both these motors, the end bell is set at 30 degrees, close enough. Just run up this one, and it says 35 degree average, 38, 33, 35, so it's not that impressive when they said they've got the new design of new sensor board design for improved deviation accuracy. Well, I know these analyzers people have said that they are not that accurate, but they are 10%, and I find them to be very accurate actually. I've had motors that are spot on. This is the timing on the other motor as supplied. This time it is saying 30 degrees, but still a deviation. 28, 33, a bit closer than the other one. Now this is the, which one is this? This is the V3R, and the other one was the V3T. For comparison purposes, I set the M-bell timing to get 6 amps current draw, and then we can check the kV and compare it to other motors. The kV is the revs divided by the volts, so in this case 7.7 volts and 23,435. If the voltage was higher, the revs would be higher as well. So you have to be careful if comparing revs and motors that you're comparing them at the same voltage. Anyway, 3043 is quite low. It means it's going to probably be a torquey motor, but it'll be interesting to see what the timing is. Timing on the rev version, it came out 50 degrees average, and a split of 48, 50, 52. Timing on the M-bell markings is close enough to 50, so pretty accurate. Fantom torque version set to 6 amps, doing a 291 kV, and the revs and volts as shown. Timing's come out quite high. It's indicating 55 and a spread of 56, 53, 57. The M-bell's only showing about 48, 49 degrees, whereas the tester was reporting 55. Conclusions on the new Fantom version 3. These were 17.5 turns, the R spec and the T spec. They've made some pretty bold claims about being new Stator design from the ground up, etc, etc. But the results, I've got the results here, and is there anything special? Well, they claim that the sensor board is improved for deviation accuracy. Didn't find it any more accurate than previous ones. I adjusted it with the 3 screws a few times to try and get it best I can. This one I got it from a Spec 48, 50, 52. On the torque version, the tester showed a very high reading, 55 degrees, and a 56, 53, 57, quite a big spread. Now the difference between two motors on test, well, I took them apart and measured everything. The weight varied by 1.5 grams, and we found out the difference was due to the stator, 1.5 grams, and the difference was due to 1 lamination extra on the torque one. It's 19.5 to 20 millimeters long, so that was just the weight of that. We checked the rotors, which had the same number, 19597 on both, same size and everything, and the torque was, the Gauss measurements was basically the same. I would say they were the same rotor, just not selected or anything for one or the other. The only difference now between this and the previous Fantom version 2 is the length of the magnetic part of the rotor. Previous ones were 24 mil long. These are now 25.7. Means that you've got a much wider field, magnetic field, which probably encompasses the wires better and should give you a little more power. Winding resistance, Well, they look the same, but the variations, I did find that this one, the resistance was lower than this one. There's a small variation, getting the contacts dead right, but it took some time, and I remeasured them, and this one was definitely higher resistant than that one. Can't see why. Maybe I couldn't see any reason whatsoever for that. But we're talking about very low resistances anyway. The lowest resistances I measured before were on the R1 at 0.038. Motive was 0.040, and generally much more 0.041. So this area here is what you're going to get with the windings. You can't go any thicker wire. You've got to put the number of turns on. You can't go to any shorter stator. Laminations. So I think this is just where it's going to be. If you're using the purest copper you can buy, you're not the wire's not very long anyway, so you're not going to get it any lower. Other differences. Well, measuring the kV at 6.0 amps. Tiny difference, tiny lower on the Torque version, what you probably expect. Just kV, not very much, only just over 3000, just 2912. They're not particularly high revving. If you compare them, for instance, the kVs of the much more letters, 3585, very high revving motor. The R1 was high too at 3426. Now the strength of the rotor you think would probably be pulling it down, and I did measure them over 1500 Gauss, very strong rotors. But if you check, the Motive has a 1500 Gauss rotor and the same length, I would say, 26mm measures. It's probably from the same manufacturer. Now the R1 still used the old 24mm long rotor. Was just under 1500 Gauss, but I don't know if that accounts for the fact that it revs so well. Probably. So gearing this motor is going to be different because it's much a lower rev, and you'll be in a typical gear ratio, whereas these high revving ones like the much more Motive, much more an R1, you tend to put a smaller pinion. The Motive is more normal, and in fact the Motive is very similar now to the Fantom. Same sort of kV, same rotor strength and size, same sort of resistance. So these two motors, Motive and Fantom, are very, very similar. Motive managed to be a fraction lighter in weight somehow. So is this Fantom version 3 a big step up from Fantom version 2? They made lots of claims about everything being much better and better. I've got some results of when I tested the version 2, 17.5. I tried it with different rotors as well, but the rotor it came with, V2R, it's a higher revving. What was the strength of the rotor? The rotor was, again, the same, 1500, but the shorter one. So it looks like the actual size of the length of the magnetic part of the rotor does actually bring the kV down, and hopefully gives you more torque, and you can gear it. You can notice the weight of the old Fantom was actually less, 156 grams, but so the weight has gone up on these two. So what's the difference between the Rev one and the Torque one, if you want to buy one or the other? Well, the differences are tiny, really. Probably you could just gear these motors the same, or just adjust the timing very fractionally, and they would perform the same on the track. The weight is almost the same. I can't see a big difference between the two. It's unusual to have two motors that are supposed to be different and actually perform very much the same. Timing, on the tester came out different. On the M bells, they actually came out on the marks about the same, which is a bit odd. Is this motor the new class leader? Well, is it a big step up on the version 2? Maybe a small amount. Manufacturers have got to sell their product, they've got to make big claims about them, but I would say it was a small step. And the cooling holes, yeah, that's good. Not as massive as some of the others like Much More and R1, but still good to keep them cool. The Kawasaki steel is obviously good, no fade. I can't say about the quality of the rotor, if it's a no fade rotor or not. It looks pretty much the same as all the other manufacturers now. So there you go, 2 new motors from Fantom. Should you rush out and buy one? Well, I should think they were in the same ballpark as the R1 Motive, the Much More, etc. But you will have to gear them differently. It's all about setting them up and gearing them to get the best out of them.